Hi, my name is Marcel Westenberg, and this is presentation 3.1 of the Practibar course package. And this particular presentation deals with multilocus introduction. So we're going to talk a little bit about if one genetic locus is enough, and we give an introduction to multilocus BLAST. So the use of a single barcode like CO1, 16S, ITS or RBCL does not provide sufficient reliability for the identification of the majority of regulated pests. So not for all, but for the majority. So in the QBOL project guaranteeing organism barcoding of life, which was financed by the 7th Framework Program of the European Union, several short standardized genetic markers were identified as additional barcodes for identification at the required taxonomy level in several pest groups. And DNA barcoding protocols were developed and validated in that project. And in the DNA barcoding Euphresco 2 project, test protocols for several quarantine pest and invasive plant species were added, and optimized protocols were validated. So how does multilocus BLAST works? So it's BLAST with more than one locus simultaneously, creating one single output. Yeah, so you can do single locus of different sequences at the same time, but then you get 3 different outputs. In a multilocus, you have, for instance, 3 sequences, and you perform a BLAST, and you want to have one output, so one identification based on all 3 sequences. So in QBank, you can do a multilocus BLAST, and you can do that with all the loci from the ApoDNA barcoding standard PM798. And so this multilocus BLAST is accessible via the organism group related web pages of QBank. So here we are at the homepage of QBank. And so you can, for instance, go to bacteria group, and then you can do a identification on here on multilocus or single locus sequences. And if you do that, for instance, at fungi, then you see here you can do multilocus on strains, but then you get an identification on strain level, or you can do that on species level or on group. Yeah? You want to have a identification based on strains, so you have different strains in your ID. So we want to do a multilocus identification on fungal strains. So you got a disclaimer. You have to check the box that you have read the disclaimer. And you have some settings right here. And for the fungi example I want to show, we have 2 loci. So the minimum characters to be counted we set at 2. So then at least we get hits only with strains which also has those 2 loci in QBank. So I go to Genius and I take from my unknown fungi the ITS sequence. I paste that into the ITS box, and I also have the elongation factor 1 alpha, from an unknown fungi. I copy that one as well. And I put that in the right box. So here's the translation elongation factor 1 alpha box. And you see there are more boxes. Yeah, so there you can also do identification on other loci, although those loci are not included all into the DNA barcoding standard. So I enter the two sequences and I start the identification. And so I get here the outcome. Yeah, so again, you have here similarity is 100% with the top hit accounted. So the two sequences are accounted out of the two. And then it also gives you a weight of 2 because you had two sequences. You can look to the alignment, and then it shows you first the alignment of ITS sequence, and then below that you get the alignment with the translation elongation factor 1 alpha. So we can click this again, yeah, and so this is gone, and so you can scroll through it and you see that you have a hit with a different species right here at 96.53% identity. So we can make also a tree. So we can draw a tree, again as done with a normal blast in QBank. You can choose different trees. So I take the top one, the upper tree, and here you see that my data comes in a cluster. So I have to walk through all those to see if they are all the same species, and they are. So in this case, my sequence falls into a species-specific clade. So thanks for watching this presentation. I hope you enjoyed it.